2020? June? June, all right, okay, so you will be eligible to apply. Okay? And the medium of, sorry?
This December.
This
December.
December, you finish this December, right? Then you apply for 2020 start.
I can't, I have 3 children.
You have 3 children? You want to get free PhD for them?
I can't go anywhere.
All right, okay, that's okay, all right. Good. Very good morning to all of you. Saturday morning is not a good day for lectures, especially for a topic which is called research methods, which is to some people a very boring subject, a very boring lecture. So I will try to make it as entertaining and interesting as possible. And before I start, let me do a little survey. Are you from the undergraduate class? No? Do you understand me? Yes. Yes. Should I speak in Chinese? I thought you understand. Okay. Are you in the master's program or in the bachelor program? Bachelor program, all right, yeah. That's what I was asking. Yeah. Apart from Russian and English, what do you speak? German?
English.
Yeah, English, Russian, German. What else? Okay. All right. I would like to do a very quick survey. For this group, you are in the master's degree. How many lectures in research methods have you done before? So in your undergraduate studies, have you done something called statistics? No. No. Have you done something called quantitative research methods and qualitative research methods? No. Have you done something called questionnaire design? How to design a questionnaire? Okay. So your background in research methods is 0. Okay, all right. Let me ask this group. What about you? What is your background in research methods? Nothing. Do you know what is research methods? Oh, okay. Okay. All right, so I think it's better for us to just have some very casual conversation. Is that all right? Yeah. Okay, all right.
You can tap on this.
I can tap on this?
Mm-hmm. Right.
Right click?
Right side.
Right side.
Mm-hmm.
This one?
On the screen.
No. What do I do?
Mm-hmm.
Yeah.
Why is so it works?
Yeah, but I use my. I have used this. I can't.
Or
use
finger.
Finger.
No.
Okay. Which finger? Anyway, why do we do research? Do you know what is research?
Yes.
Yes.
Yeah.
Do you? Yes. Okay. Don't be shy. Okay. I will be leaving this room in 1 hour, so that's okay. Don't be shy. We do research because these days it is the world trend that we are talking about evidence-based policy, evidence-based education, and so on. So whatever policy you are going to make, whatever educational decision you are going to make, you have to base on evidence. Okay? Yeah, so far okay? Yeah? In fact, all these were originated from evidence-based medicine. For example, I have gout, so I have to take medicine. I do. But why this medicine? Why not another medicine? Because after research, there were evidence to prove that this medicine is most effective. That's why I take this medicine. So my decision to take this medicine is based on research, and after the research there is evidence generated to show that this is the best. So this is what I meant by evidence-based. For example, if you are teaching German, maybe there are many methods to teach German. I don't know because I don't speak German, but maybe there are different methods to teach German. Why not method A? Why you have to use method B? Or why not method C? Why not method D? Well, first of all, you have to conduct a research. Teach the students using A, teach the students using B, and compare which one is more effective. Then after your study, after the research, you find out that method B is more effective. And that's why you have chosen method B to teach German. That's what we meant by evidence-based education. Yep. Okay. So where does evidence come from? Evidence comes from either your own research, so you do your own research, okay? Or it can come from the research of other people. So you read the research reports generated by other people. Good? Right now I try to use this one. Let's see if it works. Good. Then why do I talk about research methods today? We know research is important. Research will give us evidence. But when we conduct research, we must use some research methods. Why research methods important? That's because the quality of the methods that you use will dictate the strength of your evidence or the level of evidence. In other words, more appropriate methods, better methods, will give you higher level of evidence. That's why when you do research, you must at the beginning think of the best methods available for your particular research. That's why research methods are very, very important, because if you have chosen some research methods that are not entirely appropriate for your study, then the level of evidence generated will be low, which means I will not believe the results of your research. Good? So research methods important, right? If you don't understand, that's okay. You just remember research methods important. Yes. Okay, but what do I mean by correct research methods? You are a bachelor student, are you? Aren't you? Are you a bachelor student? Yes? You are trying to...
It's our teacher.
Your teacher, I know, but she is trying to translate.
I'm explaining.
Explain, not translate. I thought she doesn't understand my English. Okay? All right. I started my career in USA as an assistant professor. One day, I was teaching a class, a first year bachelor in the US. They call freshman. Okay, I was teaching a freshman class, mathematics. So I asked them a question. I said, students, what is 60? I better not touch it, because if I touch it, it will change. What is 64 divided by 16? The students were shocked. They said, what is 64 divided by 16? Yeah. Of course. So that's why the students were shocked. He said, teacher, we are not primary school students. We are university students. But this is a primary school arithmetic. Why do you ask us a simple question? And I said, no, don't worry. Just answer. What is 64 divided by 16? Of course, they, just like this lady, they said 4. Correct? Yeah, correct. Is that correct? Is it 4? Why 4? Why 4? Why not 10? Why not 15? Why not 200? Why 4? In fact, sometimes knowing the answer is important, but knowing why is more important. Why 4? Can you tell me why 4? Why not 20? All right. So I asked that question in USA, undergraduate students. And another lady, she raised her hand and said, sir, I know the 6 cancels with the 6, so the answer is 4. This is an example that you have the incorrect method, but you get the correct answer. Of course, this is just something funny, but the concept is important. Answer correct, yes, but if you use incorrect method, that's very dangerous. Why dangerous? Because this time you are lucky. You're lucky. Even incorrect method, you get the correct answer. But next time, will you be lucky again? No. Most likely no. So next time, if a similar question appears, you use the incorrect method, you most likely will get the incorrect answer. So that's why research methods are very important at the beginning. At the beginning, you must make sure that the methods that you use are correct. So that next time, the third time, the fourth time, if a similar question appears, because your method is correct, so hopefully the answer will be correct. So that's why I continue to ask the students, all right? Say, if you use incorrect method like this, let's see what happens. Okay, let's see what happens. So, arithmetic. Do you know something called sine, cosine, tangent, secant? You know? So I asked them, all right, students, what is sine of x divided by sample size n? Using your logic. N cancels with n, the answer is 6. This is absolutely rubbish, right? But because you used the incorrect method before, now you thought that incorrect method was correct because previously you got the correct answer. You understand my point? That's why research methods are important. That's why every time you learn something in research, not linguistics. I know nothing about linguistics. I know research. So every time you talk about research, you make sure that you understand research methods well. You understand which method is correct, which method is appropriate for what type of studies. Okay? Important? Do you want to see more of these examples? I have written a book. Every single page in the book is something like that. To give you many things that's quite funny, but funny, yes, but the idea behind is important. Okay? So research methods is not that boring if you can make it funny. Okay? All right? So what do I do? Oh, sorry. How do I go back?
Left
Left side.
Oh, left. Okay. Use the left hand.
Right hand.
Yes. No. You touch it. But what about the one before? Yeah, okay, so let me do it. Yeah, okay. Now, I am going to teach you something that will be very useful. In educational research, or in many types of social research, it is quite common that people collect data by using a questionnaire. Yeah? Do you know what is a questionnaire? Yeah. Yes, you do? Yeah. Yes? Do you know what's a... No, teacher. No.
Make it sound.
Do you know what is a questionnaire? Yes? Yes or no? Okay. Do they? You don't know.
I hope they know.
You thought they know, okay. I think they know.
I believe.
Yeah, because Saturday morning it takes some time to warm up, you know. Okay, so you know what is a questionnaire. Yeah. Have you ever designed your own questionnaire? Yeah. When you design your own questionnaire, what methods did you use to justify that your questionnaire is a good one? You know, there's one jargon in statistics. The jargon is, do you know what is statistics? Statistics, yes? Yeah, yes? Average, standard deviation. Have heard about that? Yes? In statistics, people say garbage in, garbage out. In other words, that means if the way you collect data is no good, then you are collecting garbage. When you have collected garbage, because the way you collected data was no good, so the results will not be good. So the results will be garbage. So that's garbage in, garbage out. That's why using a good questionnaire is very important. And if you are designing your own questionnaire, you must make sure that it is a good questionnaire. But how do you make sure that is a good questionnaire? That is something very advanced. But I am going to teach you how to do advanced in an easy way. Do you want to learn? Yes? So far, so good?
Yeah.
So far, do you understand?
Yeah.
Good, very good. Now, there are different types of theories in order to prove that your questionnaire is a good one. Many years ago, people used something called classical test theory. But classical test theory, as the name implies, is classical. Many years ago. It's still good, but not too good. It's still good, but not too good. It is becoming more and more common for people to use a new theory called item response theory. Right? So these two theories, I cannot go over them today because I don't have enough time, but when you step out of the room, I hope you can remember the two terms. The first term is called classical test theory. The second term is called item response theory. So maybe next time when you see a questionnaire, you try to ask people, which theory did you use to justify this questionnaire? And people will then say, what theory? Then say, what? You don't know classical test theory? What? You don't know item response theory? Oh, come on. You don't know either. But then you know the names. And these names can scare people. You want that? You want that? And you using the names, you pretend that you are good in questionnaire design. Okay? Now, if you have the chance to do a PhD with us, we will teach you the details of these two. But I'm going to teach you a little bit here. Not too much today because we don't have enough time, but a little bit. Is it okay?
Yeah.
You want to learn?
Yeah.
Is that easy enough so far?
Yeah.
Yes? Is it okay so far? So far okay? Yes? Not wasting your Saturday morning? No, okay, all right. All right, good? Yeah, okay. I'll continue. Now, I'll skip this because, all right. Let me show you this diagram. Now, you are a teacher. You are a teacher. Are you a teacher? Are you a teacher? Yeah, okay. You will be teachers. Don't know? Okay, maybe. But you are teachers. Yeah, okay. Your students, after they have taken your classes, do they need an examination? Yes? Yeah. Okay. Now, here, this is what I usually tell my students. I say, look, students usually are scared if they fail. Right? They want good grade. In Russia, it's the grade from 0 to 100 to score the marks. Yes? So people want, I want 99, I want 95, I want 85, I don't want 50, yeah, something like that. Yeah. I told the students, don't worry, because your grades, to some extent, is dictated by me. Why? Let me show you. Here, one. Oh, can I touch them? 1, 2, 3, 4, 5. Here, I have 5 scenarios. The first, what is this line? This line. This line shows the ability level. So that means if a student is here, then her ability is low. Okay? If a student is somewhere here, her ability is high. Understand? Okay, now, suppose I have a person here. So this person is slightly above average. because the middle part here is average. So here a little bit on the right hand side means a little bit above average. Above average. How to say it in Russian?
Excellent.
That sounds good, okay? Alright? Now, if here I have 1, 2, 3, 4, 5, 6, 7, 8 examination questions. If all the examination questions, the degree of difficulty is on the left hand side of the person, which means the ability of the person is higher than every single question in the examination. So theoretically, this person will get 100 marks, correct? Because the ability is here. The difficulty is all here. So the difficulty is always below her level. So theoretically, this person should get 100 marks, correct? Understand? So I said, students, easy. If I want you to get 100, I will just set because I know how good you are, hopefully. Because you are my students, so hopefully I know how good you are. So I can set all the questions to your left-hand side, you get 100. What about the second case? If I want you to fail, if I hate you, I won't fail you. Easy. This is the same person, right? Same person, same level of ability. But now I have all the questions on the right-hand side, okay? Then theoretically, you don't know. I mean, the person doesn't know these answers, so she will get 0. Of course, pure luck, she may get some scores, but theoretically, 0 mark. Understand? Mm-hmm. Okay, now this one, not 0, but not too high. This one, this, etc., etc. And that's why I said, students, don't worry. I want you to learn something. I don't want to fail you, so I will set the questions according to your ability. Understand? Yeah. So it's very easy. And this is called item response theory because these are all the items. We respond to the items according to the level of ability of the person. That's why it is called item response theory. Because we respond to item difficulties. Good? Now, what is the definition of a good questionnaire? Or what is the definition of a good examination paper? This one is good. Why good? This one, the last one, the bottom one. Why good? I explain. Because all the 8 questions spread a very long and wide spread, which means there are some easy questions, there are some not so easy or some difficult questions, so that no matter what is the level of ability of the student is, I have some questions to cover, which means using this particular examination, I can now check whether I can check using the score of the person, of the student. I can check how good the student is or how bad the student is. Yes? So, designing a questionnaire, designing an examination paper is not just designing. There are some theories behind. And you can manipulate. Have you ever manipulated? Yes? No, she has not. She has not. She has not. Alright? Good. So next time, if you get a high score, you should thank your teacher because she gives you a high score by designing a question like this. But if you get a poor score, don't blame the teacher. Okay? Alright? Okay, so now you may ask me, okay, I understand the theory, but this is only theory. Item response theory is only a theory. After I have designed a questionnaire, or after I have designed my examination paper, how do I make an objective assessment whether the question is difficult or easy. Of course, because of my knowledge in the subject area, I have a personal feeling or a subjective feeling, a subjective assessment whether a particular question is easy or difficult. You are expert in your area, so from that perspective, you have some subjective knowledge. But in research, we try not to be subjective. We try to be as objective as possible. So how am I going to use some research methods to justify or to prove that a question is easy or hard using objective methods? Understand? Okay? Now this is very subjective. You say easy, it could be easy to her but hard to her. It could be easy to her but difficult to her, right? So anyway, the easy, difficult concept is quite subjective. How are we going, the research method people, using research methods to prove scientifically that it actually is easy or is difficult? There are some methods. There are some methods. So, how do I check item difficulty? How do I know that? Suppose in a questionnaire, I have 20 questions. How do I check that one question is difficult and another question is easy? How do I do that? All right, I'll show you. I'll come back to this later. But one example, I'll give you an example. Examples are always easy to understand. Okay, so suppose now I have an examination. It can be just a test or any scale. Within this examination paper or within this particular scale, there are 20 questions. Sometimes I would say there are 20 items. Or if you are asking a child to do something, it could be 20 different tasks. So anyway, 20 questions within the examination paper. All right, so what I need to do is now I ask a group of people, in this case a group of students, to try to answer every single question within the examination. Okay? Pilot means I try to implement, I try to do it on a group of students. It can be 50 students, can be 200 students, can be 100 students. It makes very little difference, but I try to make use of it by first of all testing it on a group of students. Right? Now after I do that, I will do some statistics that you have learned before, but doesn't matter, I'll show you. Okay. By using item response theory, there is a computer package or computer software that you can use to run this item response theory using the data you have collected. So you have a questionnaire or you have an examination, 20 questions within the examination, and you ask 100 students to try to answer those, and then you put all the data into a computer software which is called item response theory, and then you will get this output. Now, because we don't have time, so I am not going to show you how to run the program. But if you do your PhD with us, I will show you how to run the program. I'm trying to convince them to come to do PhD with us. Is that okay? Yeah. I try to make use of every single opportunity. We have students from Russia, so you won't be alone. We have students from Kazakhstan who also speak Russian. So you have a lot of friends anyway. Okay. Now, item 1 up to item 20. Why? Because I told you that there are 20 items within the examination paper. So this one means the first question, the second question, the third question, etc. Okay? Now, there are 1, 2, 3 columns. The middle column is called item difficulty. As the name implies, this column will tell you whether a particular question is easy or is difficult. How do you know? These numbers, they're just numbers. If you don't understand, they're just numbers. They have no meaning to you if you don't understand. But if you understand, they are very, very meaningful. item difficulty is always a number between minus. Okay. It's always a number between -3 and +3. Always. When a number is -3, that means extremely easy. When a number is +3, that means extremely difficult. When a number is 0, it means average, not difficult, not easy. Okay? Yes? Now, please, can you tell me which of these 20 questions is most difficult? Which one is most difficult?
The last one.
Which one?
The last one.
The last one. Why? Because it is 1.72, which is the biggest of all these numbers. Correct? Correct. Very good. I'll give you a scholarship. Huh? Which one is the easiest of 20 questions?
The first one.
Number 1, right? Number 1. Because it's -2.83.
So almost -3.
It's very close to -3, yes. So what do you observe from these numbers? What do you observe? Now I observe the following. A, there is a very easy question because it is close to -3. But even the most difficult question is only 1.72. It's not even 2. It's still far away from 3. Which means overall this examination is not too difficult. Yeah? Yes? Okay. Now please look at question number 12 and question number 14. What do you see? 12 and 14, what do you see? They're the same, which means the degree, they're the same, correct? Do you understand the same?
Yes.
Yes, yes, yes. What does the same mean? The same means the same. Because they are the same, which means the two questions in terms of difficulty, same. Which means, in fact, if you ask question 12, there may not be any need for you to ask number 14, because there's in some way they are overlapped. Same degree of difficulty. Okay? So by looking at this, actually, you may be able to revise your examination paper by increasing more questions on the difficult side, removing some questions which are removing some questions which are of the same or similar degree of difficulty. Now I said number 12 and number 14. Can you give me one other example that two items are similar, not exactly the same, but similar? Similar. Okay, can you find something similar?
Number 8. Number 5 and number 10.
Okay, let's see. Number 5 is...
Sorry.
Sorry, no?
There is minus.
That's a minus, that's right. Any suggestion? Yes, please.
Number 11 and number 8.
Number 11 and number 8. Let's see. 11 is -004. Number 8 is same. 04 minus. Correct. Which means now you can either remove 8 or 11 and replace by another question, which hopefully is on the right-hand side of the scale. Yes? Is it useful? Yes. This is how we design questionnaires. So designing questionnaires can be done more objectively using item response theories. Only if you know. Yeah? That's why research methods are important. That's why if you don't understand these numbers, they are not meaningful to you. So you have to learn. If you know the idea, if you know how to interpret this output, it is easy. She got the answers, right? Easy. Even I think they understand, except that they're too shy. They don't want to show that they are better than master students. Yes? No? Your teacher is very protective of you. Your teacher? Your teacher? Your teacher? Your teacher? You all, the same class. Ah. Where is your teacher? Your teacher? Yeah.
I'm from different group.
You're from different group.
From another group, yes.
Oh, right. What do you study? Linguistics?
English teacher.
Okay. You?
Same.
The same. Same. All the same. Except that one is group is German, one group is English. Ah, okay. All right. Now this is what we call item response theory. And item response theory is one form of statistics. If you have heard about something called statistics, you know something called mean, standard deviation, t-test, regression, analysis of variance. Heard about that? Have you heard about something called analysis of variance?
Well, I guess
You don't have to
I heard.
understand, you just heard about that, have you?
I heard, yeah.
Yeah, but you don't know what that is.
I'm not sure that I understand in the...
I'm sure you don't understand. But I am going to try to make you understand now. Okay? Is that alright? At least you have heard about those terms, it's important. Have you heard about regression? Yes? Do you understand regression? Yes, you do. Ah, good. Can you help me?
Our previous degree dealt with economics. So
A previous degree in economics, so your statistics must be better. Okay, alright? I'm going to test you now, okay? Alright, that's okay. That's okay. It's okay. And what about you? Have you heard about something called correlation? Yes? In the bachelor degree?
Not only just in the average knowledge.
In different levels?
Yeah.
Yeah, okay, good. Now let me test it. Have you heard about something called standard deviation?
No.
No, okay, no, not even heard about. Okay, good. Have you ever heard about something called median? Median? No, that's okay, I'm just asking. No, okay. All I have asked you are statistics. And item response theory is one form of statistics. But statistics is not the only method that is useful for designing a questionnaire. In fact, sometimes a questionnaire has to design using logic, whether you're logical or not. Let me give you some example. I will go back to the left-hand side. So, can I go to? Okay, can I go to this one, please? All right. So I touch here. I make it back here. Yeah. Okay. Yeah. All right. I was teaching in America before. I was teaching in Australia before. No, Australia. Have you been to Australia? No. Do you want to go to Australia?
yes, I want to.
You want to? You want to? Okay. All right. Okay. All right.
It's far away from us.
You want to go to Australia or America to study?
It's far away from us.
Yeah, but
in general.
in general.
The distance between our countries.
Okay, all right. So I was teaching in Australia before, and Sydney, you know Sydney. Sydney is the biggest city in Australia, Sydney. And Sydney, there's a big airport. And one day, the Sydney airport invited me to help them to conduct a research. What was the research? The research was about what sort of people use the airport, whether they like the airport or not, and what improvement can be made in order to make the airport better, right? So I was asked as a consultant. So the airport people, they designed a questionnaire. And then they showed me the questionnaire and asked me to give some comments on the questionnaire, all right? So far, okay? Now, one of the questions asked in the questionnaire by the airport was, here, how many times did you go overseas last year? This is a seemingly easy question. This question, many people thought this question is very clear. Many people thought that there is no misinterpretation of the question, right? How many times did you go overseas last year? Seemingly a very easy, very straightforward question. But I told the authority, I told them, I said, no. This question is still subject to interpretation. What do I mean by subject to interpretation? I said, okay, let me show this question to one lady and ask her. I said, lady, do you understand this question? And she said, yes, I understand. And I said, lady, can you tell me, what is your understanding of the two words last year? And she said, oh, this year is 2019, so last year must be 2018. So this is her interpretation of last year. And then I asked the same to another lady. I said, lady, what is your interpretation of last year? And then she responded by saying, oh, today is the 20th of April of 2019. Is that right? So last year must be the 20th of April 2018 to the 19th of April 2019. Yeah, last year. So she was counting from that day 1 year. So seemingly just two simple words. The word last is a simple English. The word year also simple English. The two words together sounds simple. But I asked two people, two ladies, two different ladies. They gave me different interpretations. Yes? This is one example showing you that this is not a good question, because a good question in a questionnaire should not be subject to personal interpretations. In other words, a good questionnaire should consist of only questions that are interpreted by different people same. Okay? So suppose, how about the first three words? How many times? If I ask this lady how many times, she could say 2 times, 3 times, doesn't matter, but she understands how many times. If I ask this lady, she can also say 5 times, 6 times, doesn't matter, but at least she understands how many times. So the 3 words, how many times, not subject to personal interpretation, because different people, different ladies interpret the same. They could have different answers, because maybe she travels a lot, she doesn't travel a lot, maybe, I don't know. But at least they understand. You understand me?
Yeah.
So in designing a good questionnaire is both qualitative and quantitative. Qualitative, this is an example of qualitative, which means we use logic. Quantitative, the table I showed you before, okay, item response theory, quantitative. So in fact, this is just one simple example telling you that no matter what research project you are conducting, you need to choose the appropriate and correct methods for the study that you do. But how do you choose methods if you don't know how many methods? If you have never heard of item response theory, how can you make use of item response theory? You cannot. That's why in our university, we spend 2 whole semesters, 2 subjects, very concentrating on research methods. We teach our students different types of research methods so that when they conduct their studies, they know which particular method or which particular methods to choose. If you don't know, you can't choose. There is a famous professor at Stanford University. His name is Jerome Friedman, and he always said, when I was at Berkeley, I attended many seminars at Stanford, and this particular professor, from time to time, liked to say the following sentence. The sentence was, if all you have is a hammer, hammer. If all you have is a hammer, then all your problems will look like a nail. Nail. Because you only have a hammer. So what you can do is just this. So you have to make every problem, every question that you have, you make them look like a nail so that you can use the hammer. The idea is very simple. That means if all you know is one single research method, then no matter what research you do, you just use this method so that you have to make your research fit your method, which of course is no good. It should be the method is used to suit your research question rather than the research question to suit your research method. Yeah? And that's why you really need to learn many different methods before you can choose the most correct and most appropriate method. Don't underestimate methods, because methods, yesterday I gave a talk to basically academic staff. Is that correct, Elena? Yesterday? Basically academic staff. I told them something called critical appraisal, which was the way to assess how good a paper is. And how good a paper is, journal articles, international journal articles. How do you assess how good a paper is not based on the results. It's not based on how important the question is, but based on whether the methods are good methods or not. So a paper is good when the methods are good. Okay? Now you know more about research, or at least you know more about the importance of research methods. And when using inappropriate methods, that could be quite dangerous. And if you are using good methods, if you know how to use them, they could be very helpful and useful. All right. Now I'm going to show. I'm supposed to stop now, but I would like to show you one more slide, if I may. Are you happy to stay for 5 minutes longer?
Yeah.
Yes.
Yeah.
You like it?
Yeah. Yes.
You can go because you don't understand. Stay. The lit teacher says stay. Okay, so she makes you stay, not me. Okay. Now I say that this is very good for you, but you may not understand because I'm going to mention many names in statistics. Here. Okay. This table, now you don't have to take the photo because I have already copied this file in that particular computer. So if you want a copy of this PowerPoint file, just ask that gentleman and then he will show you, okay? All right. Now, this is the table. In this table, inside the table, they are the names of different statistical methods. For example, I asked that lady or whoever, I asked, have you heard of analysis of variance? I asked you, right? Whether you heard about analysis of variance? She said yes. I asked this lady whether you heard about regression. I asked that lady whether you heard about something called correlation. So all these are names of statistical methods. Many. 1, 2, 3, 4, many. Anyway, many. What about the 3 columns and 3 rows? In fact, I always said, I told you, no, I didn't. I told the group yesterday that I do not have an education background. In the last 20 years, I have been in the medical school. My background is in epidemiology, epidemiology, the study of diseases, medicine, public health. But there is an analogous between a medical doctor and statistics. I tell you why. Suppose I am a patient. I go to see a doctor. So this lady is a doctor. So I go to see the doctor. The doctor will ask me, which part do you feel unwell? Maybe she will test my temperature. Maybe she will test my blood pressure. Maybe sometimes even the blood test, etc. So she will ask me some questions and she will do some biological tests on me. After that, then she makes a decision or judgment which particular drug, which particular medicine is good for me. So she makes the decision that this is the best medicine for me. But she makes this decision only after she has asked me some questions and do some tests on me, right? Same in statistics. There are many statistical procedures. You choose which one, not just immediately. You have to ask some questions and depending on the answer of the questions, then you choose one of these methods. This table is showing you how to ask questions and how to make use of the answers to the questions to choose which statistical procedure. All right? Here we have 3 columns, 1, 2, 3, and 3 rows, 1, 2, 3. The 3 columns refer to the reasons why we do research. We do research, sometimes we want to comparison. Maybe I want to compare Russia and Hong Kong. Maybe I want to compare female students and male students. Maybe I want to compare master students and bachelor students. I mean, there are many examples you can think of for comparison. Okay? Another reason for doing research could be to find some association, to find out whether there is a relationship. For example, we know that lung cancer is associated with smoking. Well, now we know, but 50 years ago they did not. So we want to find out whether one thing is associated with another thing. Smoking and lung cancer, depression and anxiety, they are associated. Maybe we want to find out. Okay? So sometimes the reason for doing research is to find association. Sometimes we want to reduce, called data reduction, to reduce. What do I mean? I show you a questionnaire before that consists of 20 questions. Let me ask you, try to think. If you have a questionnaire 20 questions, and I have a questionnaire 40 questions, but the 20 questions you have can get enough information for you to do your research. Do you think you need 40 questions, my questionnaire? No, you don't. Because 20 questions shorter, the time taken to complete 20 questions will be shorter, which will be obviously better for your respondents. Yeah? So sometimes you want to know, now I have 40 questions. Can I reduce to 30? Can I reduce to 20? Can I reduce to 15? If the answer is yes, you do it. How can you make a judgment so that you can reduce the questionnaire size? Well, use item response theory. Remember, if the item difficulties are the same, you can remove one of them. So anyway, sometimes we want data reduction, which means to reduce the number of questions. I still remember when I was also teaching in Taiwan before. You know Taiwan? Mm-hmm. Heard of Taiwan? Taiwan, okay. One day, Taiwan, you know Taiwan. Have you been to Taiwan? Yes, you have been. Ah, okay. Oh, no. Okay, no. Okay. All right. There was a questionnaire on dementia. Do you know what's dementia? Usually for older people. There was 20 questions. If the question is answered correctly, the score is 1. If the answer is incorrect, 0. So the total possible score for the questionnaire is 20. Because 20 questions, 1 score for correct answer, 0 for incorrect answer, so the total is 20, right? Possible total. If a particular person, me, answers only 3 questions, so my score is 3, and if she answers the questions, her score is 15, then my degree of dementia is serious and she's normal. Understand? Mm-hmm. That means even with 20 questions, we can add up the 20 questions to form one single score and make use of that single score as an indicator of whether a person has dementia or not. This is also good because you don't need to analyze each of the 20 questions. You only analyze the total score, which is only one single number. But that single number comes from all the 20 questions. This is called data reduction. Huh? Yes? So sometimes you want to do that, sometimes. So what about these 3? Numerical means numbers. The height, for example, I am 180 centimeters, so my height is 180. Maybe her height is 172, so she's 172. All these are numbers. My blood pressure is 120, her blood pressure is 110, so they're numbers. What about category? Categorical, easy. Male, female, so gender is categorical. Bachelor, master, doctor, categorical. Yeah? I mean, you can say 1 is male, 2 is female, but that's arbitrary. You can easily say 2 is male, 5 is female. It makes no difference as long as they are male and female. So those are categorical. The way to, I'll explain this later. The way to use this table is, if you are doing some comparison, where is it? If you are doing some comparison, and if you are comparing numerical data, you use some of these methods. For example, if you are comparing the height of female students with male students, then compare and numerical. So you use these methods, okay? If you are trying to find the correlation between blood pressure and height, blood pressure is numerical, height is also numerical, association, so you use these methods. Understand? Yeah? Does this help? A little bit, at least a little bit. But between each, because I don't have enough time today, so if you do a PhD with us, I will teach you the details. I also do advertisement every time. Now, what is sensor data? Sensor data is very, very, very important these days. Yes, the word sensor, okay? What is sensor data? It comes from medicine. Suppose I'm a medical doctor and I treat cancer patients. You know, one way to treat cancer patients is you use chemotherapy. Yeah? Yes? What is chemotherapy in Russian? Chemotherapy. That's the same. Yeah, okay. So, suppose there is a patient here, and then I give him chemotherapy in the hospital, and then after chemotherapy, discharge, go home, and usually we will give a phone call to the patient and ask him, how are you doing now? How are you doing today? Something like that. We do it 3 months, 6 months, 9 months, 12 months, for 5 years. That is the standard. This is called follow-up. Now, why do we want to do that? Because we want to see whether chemotherapy is effective in keeping them alive for at least 5 years. That's very important. Suppose one day I ring, hello, Mr. A, are you still alive? Oh yes, I'm still alive, I'm very good. Oh good, congratulations. Then next month I ring him again, please Mr. Smith, Mr. A, are you still alive? And his wife said, oh I'm sorry doctor, he is dead. Then I know how long he can survive. Okay? But suddenly, one day I rang Mr. A, are you still alive? Then Mrs. A said, oh, sorry doctor, my husband died, but he did not die of cancer. He had a car accident yesterday. Ah, this is bad, because he did not die of cancer. He died of car accident. So I only know that he can survive up to that point. If there's no car accident, I don't know how long he will survive the chemotherapy. Understand? So I have partial data. I don't have full data because no one will know how long he can live if there's no car accident. Understand? This is called sensor data. Now sensor data, you can say, Professor, we are in education, we are university, we don't talk about cancer, so we do not have sensor data. No. Maybe I use a new method to teach this lady. I want to see whether her mathematics score will go up. But maybe tomorrow she's still in Nizhny. Next year she's still in Nizhny. But 2 years later she moves to Australia. You want to? Anyway, so but she goes to Australia. I cannot follow. I don't know where in Australia to find her. You know? So I only know that her mathematics score goes up after 2 years, but then after 3 years, 4 years, I don't know. That's the same concept, same idea. That's sensor data. Now, if we conduct longitudinal studies, if we conduct follow-up studies, sensor data is a big hurdle, it's a big barrier. And we need to know how to handle sensor data. And then these methods were designed to handle sensor data. Okay? So this table, with many statistical procedures, this table helps you to pick the correct statistical procedure, when you know the aim, the reason for doing the research, and the type of data that you are collecting. And by using this combination, there are 9 combinations, 3, that's 9. Based on these 9 combinations, you can choose. That's why this table is very useful. But unfortunately, we don't have enough time to go into the details. So if you want to know more about the details, but you don't want to go to Hong Kong, you talk to your rector, ask him to invite me to come back. Do you think you learned something today? A little bit something? Yes? Yes? You think that you learned something, but you don't know what you learned. Yes? Do you think you learned something today? Yes? Good? Research methods. Now I am going to stop now because I know another lecturer will come to talk about something more interesting with you. That's more related to linguistics, more your area. But this is important, very important. If you don't do research, that's okay. But if you do research, this is very, very important. All right? Good. You have a very good weekend. Thank you for paying attention. Thank you. Yeah, I need the USB back, sir. You have lovely students. Thank you. Thank you.
Выйти надо?